this discussion is about structures. Let's go ahead and just read through these items here very quickly. So, with structures, it's kind of like an array in that we're looking at a collection of variables under a single name, except that there's one difference. With arrays, the data types are homogeneous, which means they are of the same type. With structures, they're heterogeneous, which means they could be of a different type. So, for example, with arrays, we may have 5 ints or 5 doubles or 5 chars. With structures, we can have an int, we can have a double, we can have a char, we can have a pointer variable, and all of these would be collected under a single name. Then the other piece that we need to keep in mind with regard to a structure is kind of like a type. Like int is a type, and then we declare a variable of that type. A structure is the same way. We actually go ahead and define this brand new type that is comprised of all these various members, and then we declare a variable of that type. When we want to go ahead and get access to the various members, as you all remember, with arrays we go ahead and use the index notation. With structures, what we do is we go ahead and use the dot notation and then the name of the variable that is inside of the structure, which we'll find out in just a second. And then finally, when we actually go ahead and pass entire arrays, single-dimensional, two-dimensional, three-dimensional, they are passed by reference, which means that whatever changes are made inside the function, they will affect the original array. With regards to structures, you're able to go ahead and embed an array inside of it, and then when you go and pass the structure, what happens is everything is passed by copy, which means that if you were to go ahead and modify the array that is sitting inside of the structure, in essence you would be just changing the copy and it would not influence the original variable. So let's go ahead and take a look at the syntax down here. What we have done is we have just gone ahead and created this type, and this would be the syntax that would be used. And so the name of this type is called employee, and this employee type is comprised of several members. One is an employee number, the other one is gender. And you notice the heterogeneous nature of a structure in that we have an integer and then we have a char. Let's skip this here for the time being. Then I go ahead and declare 3 variables, employee 1, employee 2, and employee 3. So 3 variables I have declared of type employee. And what is employee? It is this brand new type that I've created. Now employee 1 by itself really doesn't have a whole lot of meaning. Employee 1 has meaning within this collection that we have defined inside of it. So employee 1, which is of type employee, now is comprised of an employee number and a gender. The same thing is true with employee 2, the same thing is true with employee 3. And so if we were to go and take a look at the visual up here, so this would be an example of the 2 items that are inside of employee 1, employee number and gender. And so here's employee 1. You notice it kind of looks like an array in that we have the beginning pointer here, and it contains where the whole entire structure is beginning. So employee 1, and then we can get access to employee number or gender. And then to be able to get access to any of these members, we go and use the dot notation. Now note that we have 3 variables that we have declared, employee 1, employee 2, employee 3, and so we have employee 1, employee 2, employee 3, each one of them pointing to these areas which actually have a collection of their members. Then we can actually go ahead and do all kinds of things. So in this case, we're modifying employee number for employee 1. So employee 1 dot employee number, we're making it contain the number 12. The gender is going to go ahead and contain F. We do the same thing with employee 2. The employee number is 22. The gender is M. So it's just like any other assignment, except that we need to go and prefix it with this parent variable and then use the dot notation. We can also go ahead and display it. And then here's how we go ahead and pass an entire structure. Just like an array, we go ahead and use the name of the structure, in this case employee 1. And as we mentioned before, a structure is passed by copy, which means that on the other end you're saying, all right, so what am I passing? Well, I'm passing a structure of type employee. And so there it is. I pass it and I catch it inside of emp. And so emp now has a copy of employee 1. So emp dot employee number, emp dot gender. So emp dot employee number would be equivalent to 12. emp.gender would be equivalent to female. So it's its own copy that's being passed. And of course, there's the type. And then I go ahead and just modify the gender to become a male. So at this point, emp.gender is M, and emp.employee number is 12. And so this is a local variable, and I've decided to actually go ahead and send back this employee that has been passed in. And so I do a return emp. And so here's the return type. I'm saying that this emp that is being returned is of type employee. And so I send it, and I receive it on this end, which is employee 3. So employee 3 now contains this copy that we have. And the reason why we need to return it is because structures are passed by copy. And so we need to go ahead and assign it to another variable to make sure that we preserve the changes. And so employee 3, of course, is of type employee. And so now it contains the 12 and the emp. So we have 3 separate variables.